Hello, student. Welcome to Dr. Chemist 2025 channel. I hope that you are doing well. Today, I want to talk about the rate of the reaction in chemistry and how to calculate the reaction. This is the first part, and I recorded more videos for this part too. Okay, let's get a start. Uh, I want to talk about how to calculate the rate of the reaction. This is the first part. Again, this is a Dr. Chemist 2025 channel, and I'm Hamid Reza Motifar. Please do not forget to subscribe in this channel to support this channel to create more videos, and please hit the bell. When you are hitting the bell, you do not miss any new video that I put in the channel. Thank you very much. Okay, first of all, wait, I want to talk about the rate of the reaction. As you heard in the physics, what is the speed of the car? Speed of the car. How do you calculate it? The changing of distance over the changing time. Changing time. As you remember, when you want to calculate the speed of the car, you need the changing of the distance, over the changing the time. In chemistry, we have to do like this. For example, in the reaction A plus B gives C plus D. As you know, A and B are reactant, and C and D are products. So, when you are calculating the rate of the reaction for the reactant and product, you have to write the rate, the average rate. The average rate, it means the average by the rate in the moment. So we have to write R on the above is a dash. It's the average rate. Average rate for A is equal changing of something of A over the changing of time. As you remember in the physics, changing of distance for the car, because the distance has been changed over the time. For the A, it can be changing of something of A over the time. So it should be something, for example, the best thing over the time can be changed as a mole. And chemists like mole. So the changing of mole for the A over the changing of time. And for the A, please pay attention. For the A, the changing delta NA over the delta T. The delta NA should be N2 minus N1 for A over the T2 minus T1. As you remember, okay, just a second, sorry. As you remember, for the A, by changing the time, A is used over the time. For example, in the T0, the mole of A, for example, is a 5 mole. After, for example, I don't know, 3 minutes, the mole for A should be 2 mole. So it means the time is going up. It's going to start from the 0 after 3 minutes. So the time is, the changing of time should be positive. But the mole for the A is not positive. Here, if I want to calculate it, I have to write n2 minus n1. So n2 is a 2 minus 5 for A. 2 minus 5 should be minus 3. So the numerator should be negative. And the T2 minus T1 should be time. T2 time in the bigger 3 minus 0. It should be 3. It should be positive. Let me see. I have to change the color. For the A, the time should be positive. But 2 minus 5 is minus 3. The meaning when the rate is minus, not meaning, is meaningless. So I have to multiply by minus just for reactant. Look, that's why that I bring minus here. So it should be 2 minus 5, it should be minus 3 multiplied by minus, it should be 3 over 3. So for the reactant, such as A or B, for the reactant, such as A or B, you have to put minus here on the numerator. But for C or for B, like this, minus delta NB over the delta T. It should be minus N2 minus N1 for B over T2 minus T1. But for rate, for C, it means the changing of mole for C over the changing of time. The changing of mole for C should be N2 minus N1 for C over the T2 minus T1. And you know, so in the reaction, the C is product. For example, in T0, the C, the concentration of C is 0. After the 3 times or after the 3 minutes, for example, it increases to 10 mole. So N2 should be 10 minus N1 over the T2 3 minus 0. For the product, the numerator should be positive. You don't need to put minus. So I have to write positive here. Just emphasize that for the reactant, there's a minus. For the product, it should be positive. That's why that I write for product positive delta NC, for the reactant minus delta Na over delta T. And for the or D, for example, average rate for D should be positive delta ND over the delta T. It should be N2 minus N1 for D over T2 minus T1. And during a time, the D is a product, so it increased. The concentration of D is increased. The concentration of C is increased because they are product. But the concentration of B and concentration of A is decreased. That's why that we bring minus here for A or B. We have to write the minus here. But for C and D, they are products. So we have to put positive here. Okay, let's bring two questions. Look at this one. It says, let's use my laser pen. In a reaction, after 1.5 minutes, the concentration of one of the substances increases from 1.2 mole to 2.1 mole. What is the average rate of the reaction in moles per second? Okay. First of all, it says in a reaction after 1.5 miles. So it gives you the delta T is 1.5 minutes. The concentration of one of the substances is said increase. What does it mean, increase? It's a product. Because the product increased during a time, but the reactant decreased during a time. So it should be product. From 1.2 to 2.1. Look at here. The concentration is increased from the 1.2 to 2.1. So it should be product. If this question did not say increase substances from 1.2 mole to 2.1 mole, so you have to say, oh, it's a product because the concentration is increased. But it says increases, so it should be product. What is the average rate? So it's looking for the average rate for the X. We don't know what is that. By the unit mole per second. We don't know. We are looking for this one. Okay, let's get to start. Rate for X. Rate for X, it should be delta NX over the delta T. The X is the product, so it should be positive, not negative. it should be n2 minus n1 for x over the t2 minus t1. It gives you the changing of time. It didn't give you the t2 and t1. It gives you the changing of time, delta t. It says 1.5 minutes. On the top, n2 minus n1. n2, it means mole. 2.1 n2 minus n1. 1.1, 1.2, sorry. It should be positive. And you know, 2.1 minus 1.2, it should be 0.9 mole. But look at here. You have to change the unit because you're looking for the mole per second. But here is a mole per minute. So you have to change the minute to the second. So you're using the factor label method. So you have to delete the minute. So you have to put the minute in the bottom and you're looking for second. And you know, 1 minute is equal 60 seconds. And by doing this, look, you have to eliminate minutes and you create the second. Because I'm looking for the rate of the reaction by the unit mole per second. If I write in 1 mole and continue with the 1.5 mole, so my unit should be mole per minute, but I'm looking mole per second. 1.5 times 60 should be 90 seconds. Look, mole second. You're looking for mole second. So it should be 0.110. It should be 0.01 mole per second. Hope that you understand what I'm doing here. And okay, let's bring to another example. It says, what is the time required to prepare 0.8? To prepare 0.8 moles of substance produced at a rate of 0.16 moles per second. So in this question, what do you have? You're looking, what is the time? So you're looking for delta T as an answer. What is the time required? So you're looking for delta T. To prepare 0.8 moles, 0.8 moles of substance produced. So this substance is produced at the rate. It gives you the rate. The rate of this one is 0.16 mole per second. So you have to write rate average for the x should be delta n x over the delta t. Sorry. And the delta t is your looking for. You're looking for the delta t. And you have the delta nx. It gives you 0.8 moles. So in this question, you're looking for delta t. Delta t is equal delta nx over the rate of the x. Delta NX should be 0.8 mole. Rate of the reaction should be 0.16 mole per second. Look at the unit. Oh, where's my pen? Okay, it's here. You know, mole over 1. Mole by mole is disappear, cancel. So you have this second, it goes above. So 0.8, 0.16. It should be 1, 2, 0.1, 0.02. It should be 1.02. It should be 5 seconds. 5 seconds. After 5 seconds, you have to provide 0.8 moles of substances. Hope that you understand these two questions. That was a part 1, and I create the part 2 for you in the future. Have a great time and see you soon. Bye bye.